Okay, so we saw the example of how when you increase the sample size, what that does to that shape, that center, and the distribution there as we're laying it out, right? That spread. So let's put this, just like we did in the last one, let's put this into words of what we can actually pull this off. So a sampling distribution of p hat for a simple random sample of size n with a population proportion p. There's the difference, right? You have a population proportion. The shape of the sampling distribution is approximately normal, provided that this formula works. So that has to be applied prior to even doing any other work. So this is step one, making sure that this is normal. All right. That makes an impact. All right. Then the mean is the same as the actual proportion, which we saw on that last example, right? Those were all the same. The center is that mean, and that is our proportion. The standard deviation, however, is given by this formula, where it's the square root of p times 1 minus p over the squared over n, all underneath that radical. Here's something I'll make this bigger that I want to point out. Check this. P hat. So just like before, when we had the mean of x bar with our sample mean, this is the mean of p hat because we're talking about a proportion here, right? Symbols make a difference. Symbols make a difference. Okay, let's do an example. All right, suppose the proportion of Americans who believe that the state of moral values in the United States is getting worse is 0.76, just like on that last example, based on a study conducted by the Gallup organization. Suppose we obtain a simple random sample of n equals 60 Americans and determine which believe that the state of the moral values in the U.S. is getting worse. Describe the sampling distribution of the sample proportion. When you are asked to describe the sampling distribution, that is what's happening with this business up here. You have to state that it's normal, you need the mean, and you need the standard deviation. That's what describing the sampling distribution means. So I don't have to do any work on this particular one. I'm just describing that sampling distribution. So step one is I have to determine if this is normal. There are two steps in order to pull this off, and one that we have done previously that's not stated here. However, the first thing in order to determine if this is normal is the sample size less than 5%. Is the sample size less than 5%? That's the question. So, and if we're looking at this, my sample is 60. Do you think that's less than 5% of all Americans? Yeah, less than 5% of all Americans. Yeah, we're good. We're good, right? Then step two comes right from our value up above. So NP times 1 minus P has to be greater than or equal to 10. So we plug in what we know. N here is 60. P is 0.76. 1 minus 0.76 has to be greater than or equal to 10. Okay, plug that in your calculator. Tell me what you get. 10.944. It doesn't say it has to be substantial. It's greater than or equal to. Notice that it could equal 10. And this is bigger, slightly bigger, but bigger nonetheless. So yes, all of this together, it means yes, approximately normal. All right, so given that, now we go on to the next thing. So then we look at the mean. If the mean of p hat is equal to p, what is p in this instance? 0.76. There's the mean. Equals p, boom, there it is. The mean is nice for both of these, right? So the proportion here, just like in the mean, it's exactly what you get for the population. That's cool. All right, let's do the standard deviation then. Standard deviation of p hat is going to be the square root here of p, which is 0.76, 1 minus 0.76 all over 60. Now, here's the deal. Do this in your calculator. We're not doing this in StatCrunch, right? This goes in your calculator, so plug that in. Make sure, if you have that fraction bar, that makes our life so much easier. We can just plug it into the top and the bottom. But if not, make sure that you're putting this numerator before you do the rest of this stuff, right? Okay, and then what do you get to 3 decimal places? So standard deviation is 0.055 is what I get. Is that what you get? Okay. Let me fix that symbol because that looks really bad. Standard deviation of p hat, because it was kind of running together. Okay, and that is our sampling distribution, right? That's describing it. We are stating it's normal. We've got the mean and we've got the standard deviation. Boom, nailed it. All right, okay. Now let's actually get down to business. According to the National Center for Health Statistics, 15% of all Americans have hearing trouble. In a random sample of 120 Americans, so look at this, we've got this value, this is going to be our P, right? Here's our sample, that's our N. What's the probability? Ooh, at most. At most. So what does that, pardon me, what does that look like? That P hat at most, so if the highest value possible is 12%, which is 0.12, that means everything else has to be either above or below. What? Below, because at most, the 0.12. Right. Okay. Now, does it say these are approximately normal? Does it say that anywhere in the problem? It does not, so we have to state that. Okay, so we've got our 2 criteria, so let's rock this out. Determine if this is normal. Number 1, is my population, or my sample, less than 5% of the population? What's my sample here? 120. Is this less than 5% of Americans? Yes. Nailed it. Number 2, then we have that formula. NP, 1 minus P, has to be greater than or equal to 10. So plug it in. N is 120. P is what? 0.15. 1 minus 0.15. Plug that into your calculator. What do you get? I get about 15.3. The whole point is that it's greater than or equal to 10. Is it? Yes. Yes. So it's normal. It is normal. All right. Check. We've got the normal part taken care of. Let me get out of my words here. All right. Now let's do this probability. So in order to do a probability, we need a mean and a standard deviation. So I know that the mean here of P hat is 0.15, but the standard deviation of P hat has to go back to that formula, right? So I've got 0.15 times 1 minus 0.15 all over 120, and all of that is underneath the radical. So the standard deviation here of P hat is what? Plug all that in, make sure you're good. Take it to 4 decimal places. I get 0.0326. Is that what you get? That's what we should be getting, all right? Okay, so now we're going to use Fancy Pants StatCrunch. So P hat is at most, so less than that 0.12. There's our mean and our standard deviation. So let's plug it in. Again, we determined it's normal by our tests, so we're going to calculator normal. We'll bring it up over here. Our mean is 0.15. Our standard deviation is 0.0326. Whoa, good job. 0.0326. And then this is at most, so it's less than, and this is 0.12. Oh my goodness. Right? Check all that. Wowza. And then let's compute. Let's take it to 4 decimal places. Oh, we can't see that. So 1787 is what I'm seeing. So we've got 0.1787. That's a 7. 0.1787. All right. So the probability that a random sample of 120 Americans is at most 12% have hearing problems. Wait, let me say that again. The probability that a random sample of adult Americans who at most have a hearing trouble is approximately 0.18. All right. How am I going to fit that in there? It's kind of what I'm trying to see. Well, I'll just write small. There's a first time for everything, right? Maybe if I make this bigger, it'll help me write smaller. The probability that a random sample of size n is equal to 120. Now keep in mind, this is the sample of 120, right? So there's multiple samples, but a sample where n is equal to 120 Americans results in at most 12% having hearing trouble is 0.18. That's what we're looking at. This means that there's about 18 out of 100 random samples of size 120 that will result in at most 12% having hearing trouble, if the population proportion of Americans with hearing is 0.15, right? So this just means that at most, right, of these samples that I'm looking at, then if the outcome here is at most 12% hearing, then the probability of getting that is 0.18. That's what that's saying. So with that proportion, based on that sampling distribution with that proportion. Okay. All right, all right. So, little Matthew McConaughey for you, right? All right, all right. Ooh-wee. All right. Suppose, bless your guy's heart. Okay, suppose that a random sample of 120 Americans, boom, we're still on that, who regularly listen to music using headphones results in 26 having hearing trouble. What might you conclude? So here's the deal. On this problem, we are told percentage on part A. In part B, we are told numbers. Well, how do I figure out the proportion? If I'm given just numbers, how do you figure out p hat? Aha, right? So I'm given p hat up here at 12. P hat, we know how to do that. We're just going to do 26 divided by 120. We know this. 3 decimals. I get 0.217 also. Good. So we want to know, it says, what might you conclude? So we want to know if obtaining a sample proportion of this 0.217 from a population whose proportion is to be assumed as 0.15, because it's the same problem, is this unusual? That's what we want to know. Let me write that down. So we want to know. We want to know if obtaining a sample proportion of 0.217 from a population whose proportion is assumed to be 0.15 because it's the same problem. We want to know, is this unusual? So the moral of the story here is we want to compute if the probability that p hat is greater than or equal to 0.217. Because what might you conclude if, suppose that this random sample who regularly listening to headphones are having hearing trouble? So these 26 are having hearing trouble. So I want to know, if I'm looking at this, is this going to be unusual? Like, if it's beyond this, is this going to be unusual? So outside of this realm, is that unusual? Well, we'll go to StatCrunch for that. We still have, I was trying to hope we could do both of these at the same time. So this is our same problem that we have up here. So we have the same mean, the same standard deviation. So we've already got both of those in there, so I don't have to retype that in there. The only thing that's changing based on this problem is if this number, the probability, is what we're trying to figure out, and then we'll make that comparison, all right? So this is going to be, notice this always says X, that's fine. Still a probability. It's still that area under a curve. That's all that we're still trying to figure out. But we want to know if this is greater than 0.217. And I get 0.0199. We'll go with that, all four. 0.0199. Let me take this all the way over so you can see the whole thing. Which this is equal to 0.0199. So the question is, this unusual? Yeah. Why? What's the criteria for unusual again? Less than 5%. So the question is this less than 0.05? 0.01, basically 0.02, is less than that. So yes, it's unusual. We've got this probability. We know that it is unusual. So we can conclude that the proportion of Americans who regularly listen to music using headphones with hearing trouble is higher than the general population. Because what we were saying was, here, let me scoot this over. This little piece right here, right? This is the probability that we're looking at. So this probability here is unusual, so higher than that value. Based on the fact that it is higher than that value, we conclude, let me write it in a different color here. We conclude that the proportion of Americans because proportion, probability, area, synonymous, right? That the proportion of Americans who regularly listen to music using headphones with hearing trouble is higher than general population. Is higher than the general population. So hearing loss is that Americans who regularly listen to music using headphones who have hearing trouble is higher than the general population. That's what we have learned. Okay. Nice. Moral of the story. We can talk about let me squeeze this in. If we're talking about a proportion, right? So we have this proportion. We're looking at p hat. There's information about p hat. These problems come with a percent in there and this sample based on that percentage. That's how I know we're talking about a proportion, right? We're not talking about mean in here at all. It is this proportion that we can come up with, and that's how we know we take this approach. Cool, right? I think so too.